My name is Lauren Russell, and I spent the past 6 weeks at Blue Shift, a sustainable aerospace company in Brunswick, Maine. My mentor for the 6 weeks was Sasha Derry. My project this summer was to build and design a cold gas propulsion system that could self-regulate based off of yaw values, which is basically just a fancy word for spin. So essentially, if it were inside a rocket, if the rocket started spinning more than it was supposed to, the system would alert itself, and then it would be able to self-regulate by pushing out cold gas like nitrogen and get back to the place where it was supposed to be. On my first day of work, Sasha pitched me a few ideas for what my project could be, one of which was the cold gas propulsion system that I ended up creating. The one problem with that was that I didn't have any of the necessary knowledge to build something like that. I didn't know how to code, I didn't know how to use CAD, I didn't know how to 3D print, I didn't know anything about electronics or even what a cold gas thruster was. While I didn't have any of that knowledge, I did have an essential question. Is it possible to control a cold gas propulsion system with a drone computer? While that type of work has been done before, the question that Sasha was specifically asking me was, can that work be done with off-the-shelf materials for pretty much no money? And it was my job to find out. My objectives were many. Essentially, I had to learn everything that I could about what I was doing in only 6 weeks. First, I had to learn how to use a CAD program, Fusion 360, and then how to take those CAD designs that I made and actually print them out on a 3D printer so that they existed in the real world. I also had to learn how to use a tap and die to make threads on my CGTs, cold gas thrusters. I also had to learn how to understand a drone computer, something that I knew nothing about. That led to a lot of knowledge about electronics and circuits that I also had to learn. Next, I learned how to program drone computers. I got some experience in a bunch of different coding languages, Lua, which is a C and a C++, Arduino, which is another different combo of C and C++, and also a little bit of Python. Finally, I had to figure out how to put the whole thing together, which took a lot of engineering work. Really, every day I had a new objective, and I learned more than I ever could have expected when I first came into the program. For my work plan, I essentially had to build all of the physical attributes before I could build any of the electronic attributes, since I needed the physical attributes to test the electronic attributes. So the first thing I did was I learned how to use a CAD program and printed out a bunch of stuff from our 3D printer. I printed out CGTs, I printed out my BOT, my body of thing, and I printed out a holder for my compressed air container. Next, I used a die to make threads in my CGTs, which is something that I'd never done before. And I actually broke a lot of them as a result of that. I had to do 25 different iterations before I got it right. But eventually, I was able to consistently make threads. Next, I learned about solenoid valves and how to connect them to my CGTs so that when eventually the compressed air was hooked up to them, it would flow through the CGTs. This I did by connecting the solenoid valve to the BOT to the cold gas thrusters. After that, I had to hook up the solenoid valve so that it could communicate with the drone computer. This I did using a breadboard, and I built my own circuit to connect the two. When I was using the drone computer, also known as a flight controller, I did a lot of soldering, which is another thing that I'd never done before. Hot metal was certainly scary, but I definitely got the hang of it. Finally, I had to attach all of the pieces that I'd created together, which involved using a lot of tools that I was not familiar with, including drilling through metal, which was very challenging. I found that it is possible to build a cold gas propulsion system using off-the-shelf materials. I also found that the best thread to connect the CGT to the piping was an 1/8 inch MPT thread, because MPT threads are self-sealing so that you don't need any extra materials to keep them airtight. I also found that a cold gas propulsion system can run off of one valve. It would be more efficient to use two, but unfortunately we only had one valve here during my internship. Theoretically, two would work, but my system only uses one. I also found that it's better to use a simple gyroscope rather than a drone computer to control the system. The drone computers are very complex, and it's really challenging to trick them with code into doing what they aren't supposed to do, which is act just as a gyroscope. It was a lot easier to buy just a gyroscope and use it as a gyroscope, both for coding and cost. To conclude, it is possible to make a cold gas thruster system with off-the-shelf materials.
We're testing with 120 psi, pounds per square inch. It's inside this tube. What should happen is when I turn it on, the gyroscope will recognize where it is, and if it's outside of the scope of where I've programmed it to be, this valve will open and it will send air up through here, through the CGTs, which will make it move back to the position where it's supposed to be. So as you can see, right now it's not moving because it's within the parameters of where I've told it it's allowed to be. But there you go.
I also learned that it is possible to teach oneself all of the things that you need to know to complete a project like this. The purpose of this experiment was just to get proof of concept, to literally prove that it can work.